Hi everyone. In this video, I'm going to give you some ideas for how you can convert between American units. So the units that we use in America that aren't used in very many other places in the world. Technically, they're known as the imperial, or they've been known as the British units. But again, um, we're the main country to still use these units because they're not simple like the metric units. And they have a bunch of different numbers to have to memorize because it's not standard. And yeah, and I think people have to know both just because of us. Otherwise, everybody would probably be using the metric system. And there's a whole tale about pirates that are involved in why we're still using the imperial system today. But this is for examples like converting between pounds to ounces or feet to inches. And we're going over just the basics for this. Then we're going to use perhaps similar concepts for working with slightly more complicated problems, but nothing. Well, the ones that we'll have to set up a couple of proportions with, they'll get a little trickier. For now, we're going to stick to the simple stuff in this video. There are two main methods that I typically use for teaching. One is with proportions. The other that we use more when I'm teaching chemistry is the factor label method, or it can be known as the dimensional analysis method. And I used to teach just the factor label method to both my chemistry and my T students. But then I realized that especially if we're going to need to do more complicated proportion problems, it was easier just to stick to proportions. However, there are several people that prefer the factor label method, so I'll go over the same example problems, but using this other method. I'll do that in a different video in case you decide you want to watch that and try that method instead. For now, we are just going to focus on questions that have two variables, so two units. I shouldn't say variables, two units, and three numbers will be given in the problem, and then we'll have to solve for one unknown value that will be requested. There are multiple ways to solve for the unknown number. I want you to choose the method that works the best for you, and then I want you to be consistent with it. As I wrote above, those two methods, proportions versus the factor label method, they use the opposite technique. So if you try to mix between the two, you'll get confused. There are, there are multiple ways of solving these problems. Some of you will have another third or fourth way of doing it compared to what I'm showing in this video. If it's already working for you, then please don't try to change it. This video and the other video will be for people that are more starting from scratch, that are struggling with doing these kinds of conversions and need somewhere to start. And so this will be an approach that could be used if you like it. But there are certainly other ways, and ways that might be a little quicker for people. I am showing this one in case the numbers are not easy to work with. So while it may be that a lot of the actual problems will come out to be even numbers, whole numbers without decimals, I'm planning ahead because I know that in nursing school, you'll have to do some unit conversion steps in your courses, and it may not always be 6 divided by 2. So I want to make sure you've got some different tools in your tool belt for trying to solve these problems. So here we go. One thing, no matter what method you use, you're going to have to already know that 1 foot is the same as 12 inches. 1 yard is 3 feet. It may make things go quicker. If I haven't seen this problem in a while, but just in case, you could go directly between yards and inches if you know that 1 yard is the same as 36 inches. Then you can get rid of the middleman of the feet. You'll also want to know that 1 pound is the same as 16 ounces. And sometimes I just go ahead and abbreviate instead of writing out words. So 1 lb would equal 16 oz. Here's the first two examples to give it a try. And if you want to go ahead and check them out, see if you get the right answer, then you know you're not going to need any more help with the video. If you don't, then You might want to stick around and see how I solve these, and I'll do some extra examples after that. I'll also be posting practice problems for you to try just to confirm that you know what you're doing. Okay, so feel free to pause the recording and come up with your own answer to these if you want to try it, and then I'll show you how to solve these using the proportions method if you'd like to know that way. So let's see what you got. I wanted to do these two examples that to show you that in this case, we put it in two different directions. And I know sometimes people will just automatically, when we're working with feet and inches, would automatically multiply by 12. But that won't work in both of these cases. So I just want to make sure that you know when you need to multiply by 12 and when you need to divide by 12 to get your answer. One way to always be sure that you're multiplying or dividing when you're supposed to is to try putting these in terms of proportions. With proportions, there's a couple of different ways to set them up. My current favorite is to say that unit 1 is equal to unit 2. Unit 1 is equal to unit 2. And what will happen is that these two values will go together, and these two values will go together. So what do I know? Well, I know that, go ahead and bring down another piece of paper for this. We're getting serious here. I know in the case of number 1, I have an unknown number of inches is equal to 5.5 feet. Okay, well, what do I have memorized? I know there are 12 inches, and those equal 1 foot. When I write it this way, with making sure that inches is over inches and feet is over feet or foot, that guy's sneaky, isn't he? Same idea. I can almost see already that this is a proportion problem. I could just put a division bar here and put another division bar here. What do you say we could replace the question mark maybe with the letter X? So I can put X inches over 12 inches is equal to 5.5 feet over 1 foot. And I'm going to be careful. I'll make sure that these two guys go together. The 12 inches and 1 foot go together, and they're across from each other. But again, putting down the information first in this format made this one easy. It didn't matter that the X inches was on the top left. It could be on the top right, the bottom left. All that would matter is that wherever I put the X inches, then I put the 5.5 feet across from it. And wherever I put the 12 inches, I make sure that I put it across from the 1 foot, because those are what are equal to each other. Here's how we can solve this. There's a thing known as cross multiply. Multiply. And we can do that because of this equal sign. So we're going to cross multiply to solve for X. And what does that mean? Well, that means I'm going to take whoever's across from the X and multiply it by him. So I'll end up with 1 times X. That will be equal to 12 times 5.5. So I'm cross multiplying. Well, I don't need to draw the 1 there. So I'll just write X is equal to whatever this is. And I'm guessing it's going to be something like 66, right? Okay, Google, what's 12 times 5.5? Oh, 66. If there was a number other than 1 here, then I would divide both sides by that number to get my final answer. This tells me then that 5.5 feet is the same as 66 inches. That seems reasonable. Inches are only about that big. The distance from one knuckle to the other one on my finger, whereas a foot is, of course, a lot longer than that. So I'm not surprised that I've got a much larger number. How about the second example? We've got how many feet are equal to 88 inches. Well, let's put the information a little bit differently this time. 1 foot, keeping the feet and foot, the first unit together, is equal to 12 inches. Okay, well, I'm going to just go ahead and put in my division bars there and say that x over 1 is equal to 88 over 12. I left out the units this time. The units just cancel out anyway. Inches divided by inches is equal to an invisible 1. Feet and foot, they cancel out. So I'm left with x over 1 equals 88 over 12. What do I get then? Well, I cross multiply. 12x, 12 times x, is equal to 88 times 1. Most of the time when I'm working with the 2 units and 3 numbers and solving for an unknown, it's going to be this straightforward where somebody's going to be a 1. But that's not a guarantee. And when we go on to doing 2-step proportions, then we'll definitely not have somebody equal to 1 necessarily. So that's why I'm going ahead and solving it the long way, just so you know what I'm doing in each step. All right, so here's where you're careful. Everybody's trying to run away from the x. It doesn't make sense to bring the 88 over here because that's where x is. I want to get rid of the 12. Right now he's multiplied by x, so I'm going to divide both sides by 12. 12 divided by 12, well, that'll be 1 to each of the 12. So that disappears. And 88 divided by 12, let's find out. Okay, Google, what's 88 divided by 12? 7.333333. So I'll just put 7.33. What will be really great is as you get more familiar with your most common fractions and decimals, you'll know that 0.33333 repeating is the same as 1/3. So 7.333, this 0.333 is the same as the fraction 1/3. 1 divided by 3 is 0.333. So there we go, 7 1/3. And our unit for the second one, question mark feet equals 88 inches. 88 inches is equal to 7 1/3. That makes sense. Lots of little inches make up a fewer number of feet, larger feet. So how'd you do? Okay. You may have had other ways of doing all this. You may have immediately divided 88 by 12 and then multiplied that to equal your feet divided by 1. I'm not saying there's not other ways of doing it. I'm just going to pick one and try to be consistent. Let's do one more problem together. How about we do one with pounds and ounces? So let's say we'll do it both directions. So number 3, how many ounces? I don't know, 2.2 pounds. And for number 4, how many pounds are equal to I don't know, 43.5 ounces. And what I recommend when you're working with fractions in these kind of word problems, I strongly recommend that you go ahead and convert this into a decimal. So 43 plus 1/2 is 43.5 ounces. Go ahead and work with that number as you're trying to convert it into pounds. And pause your recording. Go ahead and get your answers, and then you can check your answers by kind of scrolling, fast forwarding through the video to where you see me put the answers, or you can listen to how I solve it. Either way. Here we go. I want to know, I want you to see that you don't have to do the ounces on top. Whatever. Okay. How many? But let's do it this way. 2.2 pounds equals some number of ounces. And 1 pound is equal to 16 ounces. Remember, that has to be something you have memorized. What does that give us? 2.2 over 1 is equal to x over 16. 1x is equal to 2.2 times 16. So that'll be what, 32 and 8, so something like that. It's late at night that I'm recording this, so I'm gonna cheat. Okay, Google, what's 2.2 times 16? 35.2. 35.2, and I was searching for ounces. How'd you do with that? You okay? All right. And then for number 4, so that was number 3. For number 4, how many pounds are equal to 43.5 ounces? Okay, so 43.5 ounces equals an unknown number of pounds. And I know that 16 ounces is equal to 1 pound. 43.5 divided by 16 is equal to x over 1. Okay, Google, what's 43.5 divided by 16? 2.71875 is equal to x. We haven't talked about rounding, and I'll probably do that in a separate video, but let's say that we're going to stop at this place value. So I would say it would be a 2 point, I can either keep this a 7 or I can round it up to an 8. So I look one spot next door. There's a 1 next door. Well, that one's not a lot of support. He's less than 5. So this is just going to stay 2.7. And I was solving for pounds. Does that make sense? Well, we had a lot of little ounces, and now we have a smaller number of pounds. No, that seems pretty good. That works for me. I hope that was straightforward enough for you for how to set up the problems and solve for them. Yes, there are other approaches, but this one is pretty easy to lay out and move around. And hopefully it's a logical setup for you. Okay, thanks for watching.